Welcome back. In this video, we're going to go over section 6.3, which is about multiplying polynomials. And in so doing, we'll end up reviewing a bit of the exponent rules work that we had done in the last section. So the main tools that we're going to use in this section are, first of all, this exponent rule from last time, that if you have the same base raised to powers and you're multiplying, you keep the same base and you add those two exponents. For example, if you have x squared times x to the fourth power, you keep the base of x, and 2 plus 4 is 6. Our new exponent is 6. Okay, to multiply together these two monomials, 3x squared and 5x to the seventh power, we're multiplying. Multiplication is commutative, so we can reorder the x squared and the 5. So we'll have 3 times 5 times x squared times x to the seventh. Then 3 times 5 is 15, and x squared times x to the seventh gives x 9. So what ends up happening is we multiply together the coefficients and add together the exponents. That's the main tool that we'll need to help us multiply polynomials. And the second piece will end up being the distributive property, really. So let's try just a couple here. So here in A, we want 3x squared times negative 2x. Actually do that up here, there's room. So 3 times negative 2 is negative 6, and then x squared times x is x cubed. So here again, we've multiplied the coefficients together and added the exponents. Okay, 4x, let's do b down here. 4x times 2x cubed plus 4x times 7. We're multiplying 4x times 2x cubed. 4 times 2 gives 8. And x times x cubed gives x to the fourth power. Next term, 4x times 7 will be 28x. Okay, and that will be it. In C, we're multiplying negative 5x times this trinomial, 2x squared plus 7x minus 1. We'll have negative 5x. We're using the distributive property, so the thing outside gets multiplied by each thing inside. And I realize that you're going to get real tired of writing this real fast, but we'll see that we don't have to write it every time once we get the hang of the pattern. Okay, so negative 5x times negative 2x squared will be negative 10. And then x times x squared is x cubed. Okay, negative 5x times 7x. Negative 5 times 7 is negative 35. And x times x gives x squared. Negative 5x times negative 1 is going to be positive 5x. So here we've gone as far as multiplying a single monomial times a polynomial, and we saw that how we can do that is using the application of the exponent rule that we learned and the distributive property. What's next to see is how does it work if there's more than one term in the two polynomials. And it turns out that there's a handful of different ways of organizing our work. I'm going to show you all of them because some people prefer one way over another. And so I like to show different ways. All right, so the first way is going to be using the distributive property. We're going to multiply 3x plus 2 times 5x plus 4. And first of all, we'll use the distributive property. The distributive property says the thing out front, A, getting multiplied by b plus c, we'll multiply that by the b that's inside and the c, and then add them up. This time, the thing out front is the 3x plus 2. So we will have 3x plus 2 gets multiplied by 5x. Then 3x plus 2 gets multiplied by 4. So the thing outside gets multiplied by each thing inside, and then we add them up. It just looks a little weird this time because the thing outside is itself a binomial. This gives us two smaller distributive property questions we can do. 3x times 5x will be 15x squared. 2 times 5x is 10x. 3x times 4 is 12x. And then 2 times 4 is 8. combine like terms to finish. We'll have 15x squared and 22x's and 8. Okay, that's the first way of organizing work. The key fact in doing this is that when we're multiplying together polynomials, we need to have each term in one polynomial multiplied by each term in the other. And so using the distributive property guarantees that to happen. Another way of doing it is vertically. So here I've stacked 3x plus 2 on top of 5x plus 4. Doing it this way is kind of reminiscent of how when you're in grade school, you learn to multiply things like 35 times 27 vertically. 7 times 5, 7 times 3, you write something down, then 0, 2 times 5, 2 times 3. Then you add the rows together, right? You do that. All right, so this setup is very similar. So here we'll multiply 4. All right, sorry about that. Zoom crashed on me once again. All right, so now we're multiplying 4 by 2. That gives 8. 4 times 3x gives 12x. And now 5x's turn. 5x times 2 gives 10x. And 5x times 3x gives 15x squared. And then just as we're doing with numbers in school, you add vertically. So we'll have 8. We'll have 22x's. There's no carries, though, when you do this, like grade school arithmetic. All right, so 15x squared, 22x, and then 8. Okay. The third way is through the so-called FOIL method. This one, a lot of people, math teachers, don't necessarily like because it's relatively limited in applicability. That is, it's only good really for the situation where you have 2 terms times 2 terms. And it's a mnemonic device, and that's all it is. It's just a memory aid that helps you remember those products. FOIL, first, outer, inner, last. And that's the order of the multiplications that we'll do. So let's rewrite the problem first. We have 3x plus 2 times 5x plus 4. So now the firsts here will be, we're multiplying the firsts out of each pair, 3x times 5x. Then for the outers, that will be 3x times 4. And then for the inners, 2 times 5x. And then for the last, finally, 2 times 4. So that'll give us the same result. It's, again, just another way of organizing the work. And the key idea is that each polynomial, each term in the first polynomial needs to end up multiplied by each term in the other polynomial. Okay, the fourth and last way I'm going to show you this is through a area or box method. Here we're multiplying 3x plus 2 times 5x plus 4. So I'm going to make a box with 2 rows and 2 columns in it because each of my polynomials has 2 terms in it. I'm going to label the columns with the terms from one factor and the rows with the terms from the other factor. Then what will happen is we'll multiply the row and column labels together. 5x times 3x is 15x squared. 5x times 2 is 10x. 4 times 3x is 12x. And 4 times 2 is 8. Once you've done that, what's left to do is add up all of those things in the boxes. And once again, we'll get the same answer as we did the other 3 times. So I like to show this in different ways because sometimes people will like one method over the other, and I'll use different methods sometimes. Keep in mind that the FOIL method, though, is useful really only if it's 2 terms times 2 terms. If it were 2 terms times 3 terms or 3 terms times 3 terms, it'll be a lot harder for you to think about what's the inner and outer and last. Okay, all right, so let's go on to see some additional examples. All right, so we're going to see a few examples. And some of these I'm going to do more than one time or more than one way, just so that you have a variety of different ways of solving these or evaluating them. It doesn't mean that the problems are that hard. And just because there's a lot of work shown, it may look like they are more hard, but it's just because I'm doing it multiple times. All right, so for y plus 5 times y plus 7, a way to do it using the distributive property would be to say y plus 5 times y plus 7 times y plus 5. So the y plus 5 that's out front is getting multiplied by the y and the 7 inside. And then once you've done that, you have to distribute again twice more. And then you'll end up with y squared and 12y and 35 for that. Okay, that's good. If you wish to do this one using the box method, we'd have, again, 2 rows and 2 columns. And again, multiply the row and column labels together. And then once again, to finish, you simply add up all the entries in the table. So once again, you'll have y squared, 12y, 35. Okay, so here's one more. For this one, we have 3x plus 4 squared. Keep in mind that this is not going to be 9x squared plus 16. We can't just square the 3x and square the 4. Okay, there is an exponent rule for products that we talked about in the last section. If you have a times b squared, you can square the a and square the b. But here, the two things inside are added, and so we just cannot do that. Right, so we'll have 3x plus 4 times 3x plus 4. Okay, that just means we're multiplying together 3x plus 4s twice, so that's how you do it. So this time, let me do this vertically. I haven't done one of those recently. All right, let's try it again. All right, so 4 times 4 is 16, and then 4 times 3x will be 12x. Now 3x times 4 is 12x. And then 3x times 3x is 9x squared. So you'll have 9x squared, 24x, and 16. All right, so that's pleasant. Okay, so here's a little bit bigger one. For this one, we have a binomial times a trinomial. So this is an example of one where you wouldn't really be able to use FOIL at all, because while we could think of this a and this a cubed as the first, and this 2 and that 7 as the lasts, I don't know what you would call this minus 3a squared. Okay, so that's kind of where a failing for the FOIL method is, that it doesn't apply in every case, but a lot of students like it. So you're welcome to use it wherever it applies. Okay, so instead we need to choose a different method. I'm going to do this one first of all using the box method. So one factor has 2 terms, the other has 3 terms. So I'll make a box that is 2 by 3. If you make yours 3 by 2 instead, it doesn't change anything. This is just the orientation I picked for it. So if you want to make it 2 across and 3 down, then that also works. The whole point, as you remember, is that we need to make sure that each term in one polynomial gets multiplied by each term in the other. So a times a cubed is a4. A times negative 3a squared is negative 3a cubed. A times 7 is 7a. 2 times a cubed is 2a cubed. 2 times negative 3a squared is negative 6a squared. And then 2 times 7 is 14. Okay, now we're going to go through and just combine all those terms. Usually I start with the highest power term and work my way downward. We'll have a to the 4th power, and then minus 1a cubed, and then negative 6a squareds, a 7a, and a 14. Okay, and that'll do it. Just for fun, this time I'm going to also do this one vertically, just so you can see how that would look. because the other vertical ones I did, it was all 2 terms times 2 terms. So I want to do one here where it's a little bigger. A cubed minus 3a squared plus 7 times a plus 2. So I'm going to go 2 times 7, that's 14. 2 times negative 3a squared is negative 6a squared. Then we'll have 2a cubed. Okay, now we're multiplying a by everything. And make sure when you do this, you try to keep everything lined up. Here we have a times 7, that's 7a. There's nowhere to put that. So I'm going to put that here. Just carefully. A times negative 3a squared will be negative 3a cubed. And then a times a cubed is a to the 4th power. Okay, once again, adding vertically, we'll have a to the 4th power minus a cubed minus 6a squared, 7a, 15. Okay. Of course, we got to get the same answer, right? Which method is better? It's totally up to you and which one you like better. Either one works. Neither of these looks especially like it's less writing. I guess a box method may be a little bit less writing. Okay, so here's one to try. Take a minute, pause the video, try this one yourself using a method of your choosing, and then restart the video and see how you did. All right, let's see how this comes out. While you were working, I went ahead and did this vertically, and I got 14x to the 4th power, 4x cubed, 23x squared, 6x, and a 3. Let me see how this looks, though, using the box method. So we'll do 7x squared, 2x, and 1, and then 2x squared and a 3 across the top. Okay, so again, one factor has 3 terms, the other one 2 terms. 3 times 2 is 6. We'll end up with 6 boxes. Okay, let me multiply the row and columns labeled together. So we'll have 14x to the 4th power. 3 times 7x squared will be 21x squared. Then 4x cubed. Then 6x. And 2x squared and a 3. Okay, so let me write all that down. We'll have 14x squared. Then 4x cubed. Then 2x squareds. Match, I'll fix that later. 2x squareds, then a 6x and a 3. Okay, all right, so that doesn't match between those two methods. I have to find my mistake and fix it. 1 second. All right, I found my mistake. My mistake was I just simply forgot about this box in the first row, second column, 21x squared. You see my check mark down here in 2x squared, so I know I counted that one, and I have the 6x and the 3, but I had not check marked the 21x squared, so that's what's missing. I should have 21 plus 2, 23x squareds. So let me fix that. Okay, so that's all better now. All right, so there was nothing especially wrong with my method. It's just that I had neglected to total all the terms. Okay. So those are some fairly good sized examples. Here are 2 more, and then we'll be all finished. All right, so for this one, it says 2xy plus 3 times 3xy plus 2. This time I'm going to use the FOIL method because I haven't done one. We'll do that first. So firsts will be 2xy times 3xy. That's 6x squared y squared. And then outers, 2 times 2xy is 4xy. And now inners, that'll be 9xy. And then last, 3 times 2 is 6. So 6x squared y squared, 13xy, and 6. Okay, you can use one of the other methods to do this one as well. Okay, here this one also is 2 terms times 2 terms, so we can go ahead and use FOIL to get this done. So x squared times x is x cubed. X squared times 2 is 2x squared. Inners, 3 times x is 3x. And then lastly, 3 times 2 is 6. Okay, and that'll do it. That's probably the simplest way to do a product of two binomials. All right, so that takes us to the end of our work on multiplying polynomials. Keep in mind that all of this boils down to really three things. There are three highlights to this section. One is the distributive property. We use that a lot. Even the other methods are really using the distributive property, even if it doesn't exactly look like it. The exponent rule, where we multiply exponents. If you have axb times cxd, this will be ac x raised to the b plus d power. Multiply the coefficients together, add the exponents. And then the other kind of key fact is when you're multiplying polynomials, each term in one polynomial has to end up multiplied by each term in the other polynomial. But that takes us to the end of this section. If you have any questions, let me know, and then have a great day.